So welcome to Athletic Wise, where like-minded people come to connect. We focus on sports science and how it applies to the sports we love. In today's edition of the High Performance Speaker Series, we will be discussing running metrics. Despite the massive popularity of running, 56% of recreational runners and up to 90% of competitive runners sustain a running-related injury during the course of their training careers. Examination of running kinematics and kinetics provides an opportunity to explore and quantify risk factors related to the development of running-related injuries and performance. Today's guest in the High Performance Speaker Series is Malc Kent. Malc is a partner at RunScribe, providing in-depth gait analysis for runners worldwide. RunScribe uses advanced wearable technology, helping runners and coaches glean valuable data once only available in a lab setting. Malc, thanks very much for agreeing to be interviewed by Athletic Wise.
Yeah, thank you very much for inviting me along. And on behalf of our very, very small company of RunScribe, thank you very much to Athletic Wise as well. Yeah.
Great. So asymmetry in terms of shock, motion, and efficiency is natural, and it's acquired through certain running patterns and or differences in leg length, previous injuries, or perpetually running on a track. So well-trained runners have on average like a 3% asymmetry, like across the board. That's what we see on a treadmill, but that kind of gets washed out on a treadmill. So what do you typically see out on the field?
Well, yeah, it's a good one. I mean, it's firstly, obviously, yeah, we see wild variations, and then we can sort of get into some of the metrics. For example, depending on the metrics that you're looking at, they can be more or less sensitive in how they react. But obviously, starting at the absolute high level with one of the most basic metrics of all, just ground contact time, appears to have sort of proven itself over many years as staying the course in terms of the value that it gives. And so always when there appears to be some sort of functional asymmetry in the runner, contact time will react to it. And it's just kind of appears to be this melting pot where a lot of different functions at different places in the body all kind of coalesce and then have an influence on contact time, which kind of almost summarizes all of them, just like you're kind of cooking something on the pot. And then, yeah, in terms of things like, as we do in RunScribe, we break out what some people might refer to in academia as the initial peak acceleration, or IPA. We break that out. So that's that initial acceleration spike on the accelerometer of a sensor when the foot strikes the ground. And we break it into its horizontal component and its vertical component. So anyone who really wants to geek out can look into sort of, vectors, tensors, that kind of thing. But we essentially just say, what's the horizontal part? What's the vertical part? And so in our nomenclature, like how we refer to it, we say that the vertical component is called impact, and we measure it in G's of acceleration. And then the horizontal component we call braking. And so we do see, particularly with impact, the vertical component, that it does tie to injury quite often, that there is something there. But exactly how it ties, obviously, is part of a really multifactorial kind of complicated system of things. But it is something that we advise people to look at quite quickly. Is there an asymmetry in the impact value? And then what's the magnitude of the asymmetry? And absolutely right to your point that there have been studies, there have been data collected around the world over the years to look at the certain magnitudes of percentage asymmetry linked to, high risk, moderate risk, low risk of this person getting injured in the future. And I've seen that play out quite convincingly with things like ground reaction force. With impact acceleration, there are definitely some indicators, I would say. We always get exceptions who just like blow the indicator out of the water. But for example, when we see people with a value where, or I should say values of left and right asymmetry of impact, greater than 20% asymmetry between the two numbers, we do tend to see that is a high proportion of people who are injured or they're going to get injured in the future. So that's a few of the metrics that I've just mentioned there. So contact time, impact, braking, which braking is sensitive to how you strike the ground, whether you're more to the heel, the foot, the midfoot, forefoot, midfoot. Ground reaction force I mentioned, which essentially, again, for anyone who's not into deeper mechanics, is really how you load like one side of the body or the other, and what is the kind of peak of that amount of load that you're able to apply and receive into the ground. So that does seem to be diagnostic. We've worked with some shoe companies, etc., who collected a lot of data. And there seems to be some support around, for example, an asymmetry criteria with ground reaction force of 0 to 5% asymmetry, 5 to 10% asymmetry, and then more than 10% asymmetry, where you can categorize people as like low risk, give them a green light, a moderate risk, or a high risk. There are other metrics, of course, that we compute and other people compute around, you know, things like leg spring stiffness, for example. I think some of the other metrics are a little bit more gray on, still more work is required to figure out what does asymmetry mean in those metrics. But I can tell you, yeah, we've seen a lot of case studies over the years where people just come along and the metric, that just doesn't make sense. There just isn't this pattern that you're looking for. There isn't a quick win on the interpretation. And then you start to have to really pull together quite a few metrics to understand what's going on.
Yeah, I think Paula Radcliffe would have been interesting to analyze there, hey?
Yes. From what we know, you know, from Andy, her, you know, her physiologist, from some of the stuff that he's published subsequently, added with video that we obviously have seen from her running, and then the change, certainly in the early 2000s with her running, how she changed, definitely would have been interesting for sure. Yeah.
Oh, that was great, Malc. So there's a negative correlation between average cadence and impact force. 180 steps per minute used to be the cadence suggested as a good starting point in terms of efficiency and loading. However, we know it's not for everyone, nor at all speeds. So how do you advise runners on cadence?
Yeah, it's a really good one. Again, it kind of goes there with a ground contact time. We put it at the very top of our list of metrics that we display when someone looks at our visuals. And the reason is because it's kind of it seems to be anyway, your first kind of port of call, if you like, for getting immediate context of what's going on. Now, I should also add that we compute just over 40 metrics at the moment, so 40, just more than. And the vast majority are pace dependent. They have some sort of pace relationship. And we were very fortunate to have some universities help us with that and actually systematically run people, like a lot of people on treadmills, actually gathering what is the correlation essentially to pace. And so again, when we look at cadence, the first thing that we do is we advise people, you know, well, what pace are we talking about? Obviously, when someone gets faster, and you know this as well as anyone, if somebody gets faster, there's two methods to go faster. They can either increase the stride length or the stride frequency or stride rate. And obviously, if you increase both together, you're going to go a lot faster. So with cadence, yeah, we first say, okay, what pace is the person running at? That gives us the context. So let's say that in metric, you know, they're running at 5 minutes per kilometer pace, which is pretty much a sort of a global kind of average amongst a lot of people. Then does the cadence or the step rates work with that? Does it make sense given that kind of a pace? And so that allows you to kind of scale it up and down and see what's realistic. So we can have some people potentially that share data with us, for example, who might have a step rate of 166, for example. And I should add that step rate is when we consider both the left foot strikes and the right foot strikes combined, which is different to some numbers that some other companies will compute, which will be a stride rate, where it's only one side. So left to left or right to right steps that are considered. And that's when we have half as much. So we might have 90 rather than 180, for example. But we compute step rate. So that's every step, both sides. And yeah, if you have an example where someone might be running 5 minutes per kilometer and maybe their step rate is 166, for example, then immediately you might look at that and think, oh, that's a little bit low. But then you might look at the pace and say, well, actually, it is low, but it's not dramatically low necessarily for a 5 minute pace. It would be extremely low. Obviously, for somebody running 330 or 340 per kilometer, you'd be scratching your head. That would be an extremely powerful runner that really muscles their way through. So that's what we see is we always come back to this kind of pace dependency. Does it fit with the pace? And to some extent, the terrain as well, of course. If someone's running difficult trail, they're running downhill on difficult trail, we'll tend to see the cadence or the step rate kick up because they're trying to stay on their feet. Yeah, so there's always kind of contextual things. So we definitely wouldn't advocate the 180. We've never done that. But we would advocate for kind of zones, sort of step rate zones that are related to the pace. that the person's running at, if that makes sense.
Oh, that's great. Yeah. What about minimalist footwear may improve running economy. However, it also induces greater loading of the ankle and metatarsophalangeal joint. Is that a balance you weigh in on when you consult as far as footwear choices?
It's really interesting, and it's very timely as well. Obviously, we had the whole energy, let's say, or the movement behind behind minimal footwear. Obviously, some of the material that came out and the book that came out about running with Kenya and stuff like that kind of just built even more momentum a few years ago. But what's really timely is some of the work that's been done into things like carbon plating in shoes recently, which we've obviously been sort of had some inside information on. We work with a lot of the major footwear brands, including Nike and others. And so and that's been interesting, because what happens obviously with the carbon plate is you take away the work that's done in the joints of the foot and essentially make the foot more of a rigid system, which appears from all the data that's come out, it's been pretty much in one camp, that it appears to show less work is done. So it's more energy efficient for that lower extremity when you augment the action of the foot. And then we see obviously the drop in things like oxygen uptake in the runner when they're measured in that way as well. So it definitely seems to be a pattern there that, if you take away that kind of augmentation, you put the foot back on the ground with very little between the foot and the ground, then you're increasing the amount of mechanical work to be done by these key joints. So absolutely agree with that. There was some interesting work done, of course, and again, some research data behind it, to say that the more foam you put and the more cushioning you put under the foot, when you strike the ground, you want to strike the ground with more force and more acceleration, because your body instinctively, or what we call proprioceptively, of course, knows that it can do that. And then you take that away, conversely, with a minimal shoe, and then the person reacts very quickly to not want to strike the ground very hard, because now they feel the full force of that on the body and how it impacts the body. So there's definitely, we can see from our side of the fence, if you like, with the data and the database that we collect, we can see the huge variation in impact numbers when somebody goes from a minimal shoe to a heavily cushioned shoe. And there's no question about that. We can be talking about someone going from, just as an example, maybe 5-6 Gs using our calibration, our numbers of acceleration, to maybe like 13-14 Gs. So it's, yeah, I mean, if people listening, think about minimal footwear, it's worth noting just how much of a difference it can make mechanically in terms of load and impact to the body. Yeah,
absolutely. What about your impression of orthotics? So looking at pronation excursion, is that one of the key indices, whether to look at evaluating whether you discourage or recommend the orthotics?
Yeah, it's interesting again. So absolutely, from our perspective, of course, collecting data and we have the ability to sort of analyze normative trends from around the world. We have about almost 300,000 data sets to work with now. And so what we see from our side when we work with helping podiatrists, for example, orthotists, whatever, in this field, is that yes, in terms of numerical values, the most useful first numerical value is the pronation excursion. And what I mean by that is basically the maximum change in angle from the foot striking the ground to when it gets to its maximum internal tilt toward the middle of the body. So we measure that in degrees, and that appears to hold up, that it's a valid parameter for people who work with orthotic prescription to deal with. We go a little bit beyond that as well. Obviously now with RunScribe, we have some visuals, some 2D visuals of how the person has transitioned over their feet, almost analogous really to sort of pressure maps essentially. And then we also look at the rates of pronation excursion, and that one is one that has surprised us in how much it shows. So when somebody doesn't have the muscular control to control the pronation, we do see that appear in the pronation excursion. The rate of pronation excursion will suddenly go up, and it can go up asymmetrically, of course, as well. But from the data that we've looked at and been involved with, yeah, definitely pronation related values definitely change when you start putting orthotics in and working with that. Yeah.
Oh, that's great. What about changing from rear foot strike to forefoot strike, for example? It may not affect economy. However, for example, it may reduce patellofemoral pain. Is that part of the feedback process when working with a runner?
Yeah, I think it can be. It's a really interesting subject because there doesn't seem to be sort of one way you can go with it, one route, one method of thinking that you can go with it. Obviously, we have people who you try and do some gait retraining, they move away from a heel strike, other problems occur, and the physiotherapist or whoever's working with them is like, okay, now we've just gone to more problems than we had before. Whereas other people seem to be able to deal with it better without having major problems. I think part of that appears to be the speed at which they make the change, and whether it's just a very sudden thing or whether they have some sort of transition through. And then when they are making the change, they're doing the retraining, whether they're doing it in an environment or on a surface that buys them some time, let's say, to accept it, i.e. a softer surface. So yeah, and then of course the magnitude. I mean, some people are mild heel strikers versus some that are really quite aggressive. But it's the link to patellofemoral pain is an interesting one. I mean, the data that we've seen, I'm not 100% convinced that it's a straight, simple correlation one to the other. Getting back to what we talked about with step rate, from what we've seen and from what I've seen, the numbers firstly support step rate change. So if you want to get rid of symptoms in the knee and have people running pain-free quite quickly from having runner's knee to not having runner's knee, is get the step rate up, because most times they're running at like 160s or what have you, and as soon as they get higher, the pain disappears. So I think that appears to have a stronger link as opposed to the change in exactly how they're striking the ground.
Yeah, that's great. So there's been a recent shift in focus from pace and heart rate more towards sustaining a goal power output in training and races. Do you believe that's a superior metric to use because it reflects like the overall work output?
That is a really interesting one as well. It's a big can of worms, that one. Yeah, so when in 2012, when I was working for a rather large watch manufacturer, then at that time, there was discussion internally about power and why were we not computing power. And then Stride very quickly came along, of course, and started and caused this whole change towards power, which I think was necessary. I think people had to start thinking about it more than prior to 2012. Whether it's really right that it takes over from other metrics, I think is up for debate. I mean, as from my own personal opinion and sort of from the data side, it's telling you about mechanical work done. It's not necessarily telling you about the nervous system or necessarily about other factors that play into a person's training. So I think on a personal level, I've settled today at having multiple metrics, of which power is one, and then building context as much as possible. But I do see the value of power. I think in certain situations, it absolutely makes sense. And I can see and understand the rationale behind people training to it. But I can also see that if you had a runner who did lots of different workouts in a week, that some of them you might want to have a power target or have some power constraint on in watts, but some of them you wouldn't want to. Some of them you would just want the runner to run without power and run to either feel or maybe impose heart rate or pace. So I can see it being there in the mix with our other traditional metrics. I'm not sure about it becoming the sort of dominant metric.
Yeah. Another tool in the toolkit. That's great. What about assessing an overall, like a cumulative mechanical load? Does RunScribe have a way to kind of take a look at that?
It's a good point indeed. We haven't sort of gone down that path of chasing that, mainly because we've seen over the years that the biggest response and uptake with us and application of our product is really in the kind of clinical research area, or kind of more hardcore prosumer, we call them kind of prosumer area, and towards injury prevention through understanding things like asymmetries. So we provide something called a shock value, which is just sort of a quick look value that combines acceleration numbers together into one value. And then you can sort of look at that over time. So one of the things that we have worked on, which maybe is related in the last year or two, is actually our what we call comparison or analytical tool, where you can look at the trends over time of any parameter. So for example, you could look at the shock value and how it's changed over any amount of time, whether it's a year or 6 months or 1 month. So from that, you could understand, how much, for example, shock in this case, but you could also do load and other things you're applying over time. And you can also look at how it changes with the workout, because of course it's got to be workout specific. Was it intervals at a track or was it a long run on a dirt road? It's going to be a different thing. So I know that there are obviously tools out there to help coaches try and manage this whole cumulative load idea, which makes a lot of sense to me from a coaching perspective. But it's not quite the same path that we've gone down so much. So I think we're definitely better set up to be more of a tool that can diagnose the root cause of dysfunction in a runner mechanically. If that makes sense as well.
Yeah, no, it's so interesting. That's great. So excessive motion, like for example, ankle eversion, internal tibial rotation, they're known risk factors. We also know in terms of hip drop in the frontal plane. So was that the impetus for the sacral pod, the new development?
Yeah, it's been an interesting one. We kind of watched other people in the past have a crack at it. And unfortunately, some consumer level products didn't survive. And then the question, we sort of look at why that is, what happened there. And so we were more kind of sitting and analyzing, do we want to do this? And if we want to do this, we want to do it properly. We want to do it the right way. We don't want to have metrics that aren't really accurate. And a key thing was how we synchronize it, because certainly from my perspective, it had to be synchronized with the foot data. So you could look across a plot and see at any point in your run what happened with the foot and the pelvis simultaneously, because we knew these two things are influencing each other up and down the chain, and we have to think of them together. And hence we really encourage people today, buy all three pods and look at the whole system. Even if you're a podiatrist, understand the whole system. So yeah, hip drop's an interesting one. I mean, it is the most talked about of the pelvic metrics. And again, if you look at literature, there is one paper in particular, actually, which links together, and we can debate how valid this is, but the paper links together each degree of pelvic drop to risk of certain injuries. And if you read the paper, you'll be quite kind of shocked. If you kind of read it on face value, like, whoa, 2 degrees of pelvic drop asymmetry, and we've got problems. I think the paper maybe was a little bit sort of overdoing it. Certainly in the data that we've measured, because we've measured and collected a lot of data before releasing the product, of course, to understand it. Then we haven't seen that it's been quite that sensitive. There are still plenty of people with significant pelvic drop, beyond 5 degrees, for example, from the starting condition, who are not injured. They are running and without injury. So yeah, it seems like certainly pelvic drop asymmetry is something to worry about potentially, and then large magnitude pelvic drops for sure. Exactly where you draw the line and say, well, what's a large number in pelvic drop? I think still needs more time. It needs more studies. It needs more data behind it.
That was fantastic. Well, I really appreciate all the information, Malc. That was wonderful, and it's very exciting, and the new technology is going to be very, very interesting.
Awesome. Yeah, and we hope that people around the world who purchase it can feed back to each other, can share knowledge, and as a global community, we can learn more. And we can learn in the field, and we can learn a bit faster. Traditionally, we're learning from the lab, which takes its time, obviously, to go through the study and publish. And so hopefully we can sort of parallel that in a way, as people using our product can just share what they learn and help everybody around the world. Yeah.
Absolutely. Adding to that collective database, I think that knowledge is powerful. Well, that's great. So if anyone would like any more information, they can go to www.athleticwise.com or go to RunScribe. I've personally used it and have had, a tremendous amount of insights because of that. So thanks again, Malc. Really, really appreciate your time. It was wonderful.
Yeah, and thank you very much, Syl. Yeah, really enjoyed chatting, and thanks for allowing me to come on your podcast.